Right. Hi guys, this is day 14. It's our last day of notes for this Math 2 Honors Bridge course. So we'll get started with block 1, interpreting slope and y-intercept. So these first couple problems here, I'd like you to try them on your own. They're both just asking you to use the scatter plot and the regression line that's been drawn on there to make some approximations. So see if you can do each of those and then I will go over them. All right, so here's what I got for each of those. So they're both giving you an X value. So the first one is about how many cats people have based on their age. So it asks about a 50-year-old person. So I found where 50 would be on the x-axis, followed it up to the regression line, and then followed that over to the y-axis. Now for this one, it's about 3.5, and that doesn't really make sense for cats. Can't have 3.5 cats. So I'd say about 3 to 4 cats is an appropriate answer there. And the next one was about how far a driver can see based on their age, asking about a 75-year-old driver, find 75, follow to the regression line, and follow that over to the y-axis, about 360 feet. If you said 350, like that's fine too, because it's a big approximation right here. Okay, so with that in mind, we're going to talk a little bit more about slope and y-intercept. So it says we're often asked to interpret the slope and y-intercept in the context of the situation, meaning like the actual story or whatever the problem is about. Let's recall what we already know about slope and y-intercept first. So first of all, just definition, slope, we say it's the change in y over the change in x. Another way to think of that, it's our rise over run. Right, that's what we know about slope already. And when we describe slope, kind of using the story or in the context, you're thinking a template sort of might be as y does something, so increases by 1 or decreases by 35, I don't know, whatever the story is, as y does something, x does something. Like that's a bad template, but that's kind of the idea. Y and x, we would have our actual like labels. So like cats, the number of cats and their age, right? Those things would be in place of the letters y and x. You wouldn't have those variables in there. Okay, and we'll do practice. Our y-intercept, we know that this is when the line crosses the y-axis. We know this happens when x equals 0. And in context of a story, it's basically like the starting point. Or again, when x equals 0, what is y? What is the value of y? Well, you'll find for the y-intercept, it often doesn't really make that much sense, but we still interpret it. Because of our linear regression equations, you might be talking about something like length of something, and the y-intercept ends up being a negative just because of our equation, and that doesn't really make sense in the context, but we still will interpret it. So let's look at some actual examples here. It says data were collected on the depth of a dive of penguins and the duration of the dive. So we're looking at depth and duration. Duration means time, how long it took them to complete the dive. The following linear model is a fairly good summary of the data, where t is the duration in minutes and d is the depth of the dive in yards. Okay, so t is the duration, d is the depth. If I'm looking at this, duration seems to be in the x position, which is our independent variable, and the depth is in the y position, which is our dependent variable. Whoa. Okay, so what does the slope represent in the context of this problem? So when I'm looking at the slope, I'm looking at this number right here. Our slope is 2.915. Now what helps me interpret the slope is to write it as a fraction. So if it's not already a fraction, and it's usually not, I'm not going to like rewrite the decimal. I'm just going to put it over 1. make this number look like a fraction. And I'm going to add the variables that are appropriate. Remember that slope is y over x. So our variable in the y spot is the depth. So this is depth. And the x variable is the duration. I know they're not x's and y's in the problem, and that's fine, but they're in those positions. So this helps me interpret it in the context of the problem, because I can say the depth, so you're going to talk about whatever's on top first, increases by 2.915 for every 1 minute, because the time is in minutes. And I should probably have put the unit for the depth. What is it? Yards. Okay, so this fraction kind of helps me set up my answer, but this sentence here is really the answer. Like, that's what I'd be looking for as a teacher grading it. The depth increases by 2.915 yards for every 1 minute. So I'm just using the numbers right for my fraction, talking about the top variable and then the bottom variable. The y-intercept in this problem is 0.15, or sorry, 0.015. And this happens when x equals 0, right? This is the y value when x equals 0. So to interpret it, I'm going to say the dive is 0.015 yards when 0, or let's say when time is at 0 minutes. That's it. So the y-intercept doesn't always make as much sense as the slope, but we basically interpret it the same way. Okay, let's see, how many more do we have? We have one more, so let's look at this one. So it says, data was collected to determine the length a golf ball will travel when hit by a golf club with a certain speed. The speed is measured in miles per hour, and the length the ball travels is measured in yards. And then here's our linear equation for the relationship. So when I look at the equation, I have S in our X spot, and that's looking at speed. And then D is the length, and that's the Y spot. So when I talk about the slope, my slope is 57.66. I'm going to make it a fraction over 1, and I'm going to put the variables with it. So the Y variable goes on top. So that would be our length. Remember, it's y over x. And then the x variable is on the bottom, that's speed. So when I interpret it, I'm going to say the length increases. And I know it's increased because it's a positive slope. If it was a negative slope, then it'd be the length decreases as the bottom variable increases. Okay, the bottom one will always increase. The length increases by 57.66 yards, so use your units, each, and then our speed is measured in miles per hour, so each mile per hour. Okay. What does the y-intercept represent? The y-intercept in this case is 3.18. So the ball travels 3.18 yards when the speed is 0, right? When your x variable is 0. Okay, and we're done.